Hello class, welcome to our lesson today. We're going to be looking at displaying data again, kind of focusing on the histograms. So let's go ahead and get started with that. We talked a little bit in our previous class period about histograms and how to get them set up kind of on your calculator and what they represent. Remember, there's a difference between the bar graph and the histogram. First off, a bar graph is collecting information about categorical data or qualitative data, whereas a histogram is a number range idea, which is a numerical data set or a quantitative data set. The main byproduct of this visually is that the bar graph will have spaces in between because each of these categories, such as these countries, would be in their own category, whereas this is a number range, which you have to kind of think as a continuous number line. And so the reason there's no gaps in this is because this number line just keeps going. And so the histogram will have only a gap if there's kind of like an outlier somewhere or a gap in the data set, not because of the fact that they're categories like the bar graph does. Histograms themselves come from what are known as frequency charts. So you look at here on the left side, this is number of students and the frequency. So whatever this is, time to do something, whatever the category is. There's different ways that you can show this. So I've shown that it's 0 to 4.9, 5 to 9.9, etc. And then these are the frequencies that we're dealing with. The key here is what is the class width and what are we starting at. So the lowest data point is 0, and then the class width is 5. There's a few ways you can come up with that, but the easiest way that I can explain it is the beginning of each class. So the class starts at this 0, the next class starts at this 5. Which means that the distance from the 0 to 5 and the 5 to 10 and the 10 to 15, all of those are a distance of 5. So because of that, what you're looking for is the fact that the class width is 5 for each of these, so that each of these pieces would be a distance of 5. The other thing to make note of is this version I have 0 to 4.9. So the question then becomes, well, what if it's 4.93? Well, 4.93 is less than the next class width, so it would go with this 0 to 4.9. Now, there's a rounding piece that you may have to deal with, which is why some frequency charts, such as some in your textbook, may show it as from 0 to everything less than 5, and then 5 everything less than 10, 10 everything less than 15, and then 15 everything less than 20, for example. So you may have to play around with that idea from the frequency chart a little bit. From there, what we're looking for is the fact that that chart is then just visually shown. So you're saying from 0 to 5, there's 5 people. From 5 to 10, there's 7, and etc. So the class width here was 5, and the starting number was 0. And then this would be the histogram if I were to draw it by hand. You should be able to do that also with a graphing utility. If it's in a frequency distribution chart, like this one, it's a little bit more challenging to kind of figure out what the histogram would look like just with the technology. But if it's already set up this way, then making it into the histogram by yourself by hand should not be very difficult. More likely, you're going to have a data set that you have to look at and then see what to do from there. Just a few words of caution about histograms. Make sure that they're from a quantitative data set. They have to be numerical. Anytime you're trying to look at two data sets and two distributions and kind of compare them, make sure that you're not using frequency in order to compare like how tall each group is, because if one group has a lot more people, you don't want to see if the distribution has more people. You want to see how spread out the data is, if it makes the bell-shaped curve or if it's skewed. Don't use frequency, use relative frequency, which is another way to say use the percentages of each group. And then you can't describe shape, center, and spread of categorical data. You have to do that only from numerical data, which is what the histogram can do for you. Imagine this scenario. Roll a die 10 times and record the results. So you're going to roll a die, 6-sided die, 10 times, record the results, and then take that data and combine it with 4 other people. In the end, you should have 50 die rolls in total. If you were to make a histogram of that idea, what would it look like and how would you describe it? So let's take a moment and think what's going to happen. When I roll the die, I should either get a 1, 2, 3, 4, 5, or 6. And what happens here is that the data is fairly uniform in its distribution, because all the probabilities of getting 1 through 6 are essentially the same, as long as it's a fair number cube or die. So because of that, yes, we're going to get times where it's less than others. Notice this is a percentage or frequency distribution idea. Yes, some of them are going to be less, but numerically, they're going to be very close to one another. This data set would have an easy class width of 1, and then just the heights would be their frequencies. Granted, some are a little above, some are a little below of what we expect to happen, but it makes a relatively standardized normal distribution. Now let's compare that with roll 2 dice and add them up, record the results, do that 10 times, and then combine with 4 other people to get a total of 50 die rolls. Make a histogram of that data, and when you do that, how would you describe it? So again, we're rolling the 2 dice. Think of them though as rolling them kind of one at a time, or they're different colored dice. And so, for example, the first die could have a 3 and the other die could have a 4, or vice versa, and you would still get an answer of 7, but there's multiple ways to get that. And here's what should happen with your dice rolling of 2 dice. Notice the data set is not perfect, but what should happen is if you keep rolling the dice over and over again, you should get a lot more numbers in the middle here, like say from 6, 7, and 8, compared to numbers like 2 and 3, and 11 and 12. This is an example of a nice normal distribution or bell-shaped curve. There should be small amounts of data on the two ends and lots more data in the middle. This idea explains why junior versions, if you've ever played a junior version of a game, like with a younger child, the junior versions of games are this idea. It doesn't take any strategy to figure out what's going on. You just roll the die and move and buy whatever you want at that spot or go to the next location. There's no strategy involved that person A could beat person B if they understood the game more. Compare that with other games like regular version of Monopoly. Catan would be another good version if you've ever played that. You know that there's more likely to be dice rolls in this middle area, say from 5 to 9, as opposed to 2 and 12. So you may put more emphasis on the numbers in the middle as opposed to the numbers far at the end. We can all think of a time when we were playing a game with 2 dice where you rolled double ones, snake eyes is what they're called, and you had to move 2 spots and then you landed on boardwalk with a hotel or something. That idea involves some type of strategy. It was very unlikely because it was in this lower end of your bell curve compared to the numbers in the middle. This question is from your textbook. This is what's known as a population pyramid. It's basically a back-to-back histogram, similar idea to the back-to-back stem and leaf plot or stem plot. This shows the distribution of Vietnam in the year 2010 in males and females. Population in millions, and then describe what you see, but you got to make sure you're specific. So the first thing you could probably say is the data is skewed similarly for both groups. This would be a positive skew. You kind of have to tilt your head sideways to look at the histogram kind of individually, but this would be kind of positively skewed or to the right because it starts with a lot of data with the lower numbers and then goes down. Both cases have that situation. So what that's saying is there's a lot more younger people than there are older people in the country. In terms of the spread of the data, it appears very similar for males and females to be fairly similar spread of the data. The one piece would be where the peaks are. And so if you notice the peaks are in similar locations, so they're kind of around this 15 to 25 range. Okay, the most groups in both male and female for Vietnam in 2010 were similar. However, look at the population. The number is much higher for males compared to females, which means there must be less of the females in the country at that time, and then you can research why that would be. So that would be a kind of a quick description about what it says about the population during that year. A similar spread of the data, a similar idea that there's a lot of younger people in the country, and then it's less because of the positively skewed nature of both graphs. But there would be more males, it appears to be in many categories early on. But then when they get older, then it kind of switches around a little bit, and there's more females in this older category compared to males. So you want to make sure you're specific in order to describe that question, and then do that same idea as you look at your histograms as you do your homework. Your questions today come from page 44, number 52 and 56, 60, and then 66 through 68. Make sure if you're asked to make the histogram, work on that with your calculator and or use the pictures that are given to you. If you need to be specific, remember you're looking for full sentences. Think paragraphs for those situations and those solutions to the description ideas for any histogram question. If you have any issues, ask a peer, or you could always ask me for more guidance about some of those scenarios. And then also don't forget to make sure you're reading directions carefully and know how to make histograms on your calculator. Have a good day, everyone.